What up? All right, last week you told me that there's a lot of formulas, and that was what was frustrating you about these things. So let's talk about there's only really two formulas for volume. Three, sorry. Three formulas for volume, even though it seems like there's a bunch more. So let me explain that to you. All right, so first of all, there's volume of a prism, a pyramid, and a sphere. So let's define those three terms really quick. So a prism is anything that comes straight up and the base is the same as the top. Okay. So, or it could be slantwise prisms too, but either way. So the base is the same as the top. Pyramids, the base is whatever shape, and then the top comes to a point, and then a sphere is just a big old round ball. So let's do those three formulas. So if I have a simple prism like a box, I would find the volume of the bottom, or sorry, the area of the bottom times the height. So the area of this is a square. Well, it might be a rectangle. So I would do length times width times height, which is the volume formula you probably remember. But I can do that with any old shape. So this is another prism. Don't worry about the top. Let's ignore the top, okay? Um, but I can technically find the area of this. It would probably be a square where I cut off the corners a little bit or I round them off. But then I can do the area of the base times the height and find the volume. And that also works for cylinders. So area of the base times the height. That'll get me the volume of this too. So there's really only one formula for prisms. Okay, now here's the crazy thing. If I have a pyramid, like if I took this and I became a glass blower and I could like squeeze the top together to make a pyramid instead of this, it's a third of the volume that it was before. So every pyramid is a third of the volume of the prism. Now the really crazy thing is that I don't really have any freaking pyramids in my house, but here's this is my plant. It's not doing so hot, but it's my plant. So if let's pretend like this didn't open up, like it kept going, it kept shutting. This would be a third of the volume of my triangular prism of the same size. It's a third of it. In class, I have these 3D shapes that can hold sand or water, and you can count how many times. It would take 3 of these to fill up the matching prism, the matching triangular prism. 3 of them, which I think is crazy because I always thought it was half, but it's a third. Okay, and then the other thing is spheres. Spheres don't really follow any rhyme or reason. I haven't been able to figure out why it's 4/3 ever. But if I have any sphere, it's 4/3 times pi times the radius cube. So I would need to find the radius or be given the radius. A lot of times it'll tell you the diameter. So that's fine. So those are the only 3 formulas that you really need to find volume. You need to remember the area of the base formulas too, and that's why they get really complicated. Because if I know the area of the base is side squared, to be side times side times side, that's the volume of a cube. If it's a pyramid and it's a triangular base pyramid, it'd be 1/3 times 1/2 base times height times the height, like the tall height and not like the base height. So it gets kind of complicated, but these are the 3 formulas. I'm going to pause and I'm going to draw a prism, a pyramid, and a sphere so that way people who aren't watching can see what they look like. And then we're going to go ahead and do some practice problems. Actually, I'm going to show you how to draw these because some of you always wonder. So I drew the base shape, and then I'm just going to go straight up, and it's always going to be the same length. I'm just going to go straight up from each of the points, and then I connect the points. So that's how I do a prism. Okay. And then a pyramid, I draw whatever base. And then I'm just going to connect all the points into one space. So that's a pyramid. And then a sphere, I honestly just draw a circle. And then I draw like the equator kind of thing here. That was really gross circle, but it's okay. So that's how I draw those. All right, let's find the volume of this thing. Now, I'm going to end up drawing this because, again, people don't freaking watch my videos, but it's fine. There's 22 of you that do, so I'm here for you. But I'm going to draw the picture over here. But for the volume of this shape, I need to figure out where the orientation is, right? What's the height of this shape? Well, the base and the top have the same shape. So what that tells me is that I need to open this up again so I can actually use my, there we go. So what that tells me is that this is the bottom and this is the top, or vice versa. It doesn't really matter. But what that tells me is that I need to find the area of this triangle and then multiply it by the height. Okay. Okay. So we know the area of the base. It's a base triangle, right? So it's going to be 1/2 base times height. Well, the base of this is going to get confusing, I know. The base of the base is the 22 and the height of the base is the 7. So it's going to be 1/2 times 22 times 7. That's my triangle. That's the base and the height of the triangle. And then the volume is going to be that times the height of the whole thing, which is 25. So it's going to be 1/2 times 22 times 7 times the 25. So let's see, that's 77 times 25. I don't know. Let's find out. So that's 1925. 1,925. Now here's the fun part. It's going to be meters cubed. Now, somebody in class, okay, by the way, I'm recording this in second trimester, so I'm hoping we have the same conversation in third trimester. Uh-oh, I might need to re-record this. In class, second trimester, somebody said, well, it's 3D. 3D is volume, right? Volume's 3D. That's why it's a 3 up here. That's why area is a 2 up there. It's 3D volume, 2D area. You get it. Okay, so I'm going to pause and draw this shape so that way I don't forget which one it is. Somebody's going to ask me if you have to draw this too. I would recommend at least a sketch. That way you know what you're looking at, but you don't really have to. Like, I don't know. I would. Also, I'm going to point out that this is not to scale, right? 25 and 22 does not look like it's to scale. Also, I want to explain, I almost bought a can of Pringles this weekend too, and I should have. So I want to explain why volume is volume, why it's the area of the base times the height. So let's take a Pringles can, and let's say I have really flat Pringles. They were made badly. They don't have like the duck face, right? They're flat. Well, when I put a Pringle in there, it'll cover the bottom, and then I'll put the next layer on, etc. Right? All the layers. So it's that area of one of the Pringles times the height is how much the volume is. Okay, so that's how I figure out what volume is. It's area of the base times the height, because that's how many Pringles I can fit in the can. All right, let's find the volume of this one. I know it's numbered. It's because it's an old assignment I used for a different place, different time. So let's find the volume of this. Hold on, I shouldn't be writing this. Okay, so this is again a prism, and I can tell because the bottom and the top are the same length. Okay, or same, they're both circles. So what this means is that the base is that circle that's 7 meters right over here, and then the height is 22. I know, okay, it's like this. I know, I recognize that it's going to confuse you because it's on its side, but 22 is the height because that's how many circles I have filling up the whole thing. That's the Pringles thing again. So we need to find the area of the base and then multiply it by 22. Now you'll remember from 6a, the area of the base is pi r squared. So we're going to do pi times the radius squared. And then for volume, we're going to multiply that by 22. So volume is the area of the base, pi times 7 squared, times the height, which is 22. So we get, I don't know, whatever 49 times 22 is with a pi on the end of it. 1,078 pi. And then again, this was in meters, so it's going to be square meters, or cubic meters, sorry. Volume is 3D, area is 2D, 3 and 2. It's like a truck flashing outside. Okay, I'm going to pause and draw this again. Okay. Let's find an easy pyramid and then a hard pyramid. So I'm going to show you both of those. Pause for cat. Okay, maybe this will work. This is a pyramid because it comes to a point. Okay, so the base of this pyramid is the 5 meter square, and then the height is the 10. You can tell it's 10 because it has the right triangle right in the middle of this. What's wrong with my hair today? Right in the middle of this pyramid. Okay, that's the true height. It's not the slant height, which we're going to talk about in the next one. It's a little bit harder, but let's do this really quick. Okay, so the area of the base is going to be just 5 squared because it's a square. Like, it doesn't say it, but it doesn't show you any other lengths either, so we have to assume at this point. So the volume is going to be 1/3 times 5 squared times 10 meters, which is, I don't know, hold on. Obviously 83.3. Now that'll be, again, this is all in meters, so meters cubed. I'm going to draw this one. All right. So last time they gave us the true height, also called the altitude. In this case, they don't give us the true height. What they give us is the slant height. This is just the outside of the pyramid, or the pyramid. So it's just this part is 6, but we want this part. We want straight from the very point to the middle. Okay. So we have to do just a little bit of math to figure it out. But let me show you how to do that. Okay, so here's what we're given, and then I need to find the true height of this. So what I'm going to do is I'm going to move my mind into 2D land. Okay, and I'm going to create a triangle because there's a triangle here, right? There's a triangle here which has a, hold on, let me redraw it. Hypotenuse of 6, a base here of 2, right? Because it's half of the diameter is 2. And this is what I'm looking for. I need the true height to be able to find this. So these are the words I've been using. So 6 is the slant height, and the altitude is what I need to be able to find this problem. So this is actually 3 steps. I'm going to find the altitude, and then I'm going to find the area of the base and the height and the 1/3 thing. So let's do that. So first step, we need to find the altitude. Now, we forget so quickly basics. Pythagorean theorem, a squared plus b squared equals c squared. I don't need to use any SOHCAHTOA on this specific triangle because I know that x squared plus 2 squared equals 6 squared. I don't know what that is. Let's see, that's 4 and that's 36. So x squared plus 4 equals 36. Subtract the 4, x squared equals 32. Square root of 32, I don't know, hold on, is 5.66. So then we can do area of the base, which is not 4 times pi squared, or pi r squared. So not 4, but 2. So it's pi times 2 squared. And then the volume will be 1/3. I almost wrote 1/2. 1/3 times that. Times pi times the radius squared times the height, which I needed to find. It wasn't 10. It wasn't 6. It was not 6. It was 5.66. It was close, but it wasn't. All right. Gosh, that was 12 minutes. Okay, I'm sorry. Hey, I hope you have a beautiful day. Email me if you have any questions. We'll do some spheres in the assignment, but it'll just plug it in, so it's not that hard. I hope. Okay, bye.